Welcome to Barix Virtual NAB. My name is Reto Brader, I'm the CEO of Barix, and I'm supposed to update you on the things we wanted to show you at NAB this year, if it would have taken place. So, we are at my home office. I'm in the lucky situation that I have a not too small home office, and we organized some equipment. So, we have a hobby camera, I even found a green screen, and I hope we can make this fun and entertainable as good as it goes. So, looking forward to, okay, yeah, that has worked all week. I think it's not going to work now. So, let me get truly dressed, and in the meantime, I want to go with you on a virtual travel to Las Vegas.
Ladies and gentlemen, good afternoon. This is the captain speaking. Just about ready to depart. Should be away on schedule in a couple of minutes.
Where the day flows, only time, and who can say?
Okay, so let's use technology to jump to Vegas. And we move on to the convention center and straight through Central Hall to the Barix booth. Well, I apologize for my colleagues being a bit stiff. If I would have known that we have to do this year, I would probably have taped them instead of just taking pictures. But here we are. It's all I have. It has to do. Let's get going. Well, Barix is well known in the broadcast market for our very reliable, cost-effective broadcast encoder-decoder solutions. And I'm here to show you some new products that we have come up or finished in the last 12 months. Let's get started with the MA400 SIP Opus codec. Like all Barix devices, it's this sturdy metal case encoding device here that provides a bidirectional audio link over IP using the SIP protocol for connection negotiation. So a few words about the SIP protocol. Basically, telephony has moved on using IP infrastructure, and they needed a way to establish the connection between two telephones. So basically the translation of a telephone number into an IP address and port information. And that's what the session initiation protocol, the SIP protocol, is all about. So instead of having to deal with fixed IP addresses and port numbers and things like this, I put a SIP voice over IP server, and I can connect a telephone, and that server knows if somebody calls that telephone number, it actually goes to this particular IP address. Sounds complicated, but it's not. It's just another way to establish a link from one end to the other. So instead of having a fixed link, I use this like a telephone. This box uses the SIP protocol to dial up another box that also has a telephone number. So first thing I need to do is register this with my telephony service or with my SIP server, and I have to do the same for the device on the other side. Now I can ask the device to establish a link, and I'm ready to go and have a telephone link between the two sides. Now that's, again, not particularly amazing because I can do this with a telephone. But the beauty is that the SIP protocol has support for the Opus codec. And the Opus codec is a high-quality audio codec that can transport talk, spoken word, and music at a very good quality. So what we have implemented is a SIP-capable device that supports the Opus codec. And I can use this to dial into my studio, for example, with a high quality audio link by using the SIP protocol. The MA400 SIP Opus codec is a PoE device, so it doesn't even need power. All I have to do is plug it into an Ethernet port that has PoE provided. Now I also plug my loudspeaker in here so I can hear the IP address that I received for this device. 192.168.1.1.8. I open a browser window, I type in the address. The device is actually password protected with a unique password, like all new Barix devices. And I'm ready to configure this system. All I have to do is, in the settings, I have to tell it to which SIP server it shall register, under what username and what extension. So this is something that you either get from the telephony service provider or that you configure on your own SIP server. I have different possibilities of how this codec should connect to SIP. I can select auto answer on incoming call. So if another codec calls this one, then it will automatically establish a connection. Or I can have a call on an input. This device has the ability to connect a button, and by pressing the button, it will establish a call. What I have done is I have selected, under all the codecs that SIP supports, the Opus as the only one it shall support, because we want the high quality audio link supported by Opus codec. The bandwidth negotiation will happen automatically. That's really all I need to do. My codec is ready. All I have to do is connect audio to it. I do the same thing on the other side. For example, one in the studio, one at the sports venue, and I have a remote call link into the studio. But of course, in Corona times, I have one at my home, I have the other one in the studio, and I can broadcast from home. It's bidirectional, so I hear the channel back from the studio, and it even has an RS-232 tunnel if I need to send control message through the system. Thanks to the SIP protocol and the standard codecs, this device is interoperable with devices from other vendors. So many of our first customers using this do not connect to Barix devices, but they connect it to a Digigram device or a Wheatstone device. Or, as I have mentioned, it is actually using the telephony system. So I could use a telephone to be the codec on one side of the link. And this is what I would like to show you in the next minute here. I have downloaded an app called Linphone, which is a telephone app. It behaves like a normal telephone, but it supports the Opus codec. I registered this to my SIP server so I can make phone calls to that device, the Barix SIP Opus codec, from my phone. Now, from a journalist's point of view, it's not very fun to walk around with a phone like this. Also, from the audio point of view, I might want to have a microphone. So here comes the beautiful part. There's a bunch of manufacturers that make devices that provide me an XLR to my phone. I have a device here from another company called Digigram, and I connect this device. I'm ending up with an XLR connector here on my phone, plugging in a microphone, I'm starting my Linphone app, and I am dialing the phone number of the Barix SIP Opus codec. One, two, three. Okay, I now have a connection between my phone and the Barix SIP Opus codec, and I can have it both ways. I can actually plug in here a headset, and I even hear what the studio says to me. A very low-cost remote broadcast encoding solution, either using the phone, or of course using two of the Barix SIP Opus codec devices. Applications for the MA400 SIP Opus codec: live audio for sports or event contribution, even SIP-based studio-to-studio links, any kind of remote broadcast application. And if I combine it with the phone, I even get a truly low-cost remote link into my studio at high quality. Now, many of you use the Barix InStreamer encoder to bring your radio to the internet. We have introduced last year the InStreamer ICE, which is our first AAC Plus encoder to bring radio to an IceCast server. Or what's really beautiful about this unit is it has an IceCast server built in. So it can generate up to 100 streams, serving 100 simultaneous users out of the box. That has made this product a very popular product, and we have added some new features that we're going to show here at NAB. The first feature that we've added is authentication. It is now possible to have a password for people to subscribe to a stream. So not everybody can listen to the stream once they figure out the source IP address or link of that stream, but it's protected by password. I can have a single password for each of the 100 users or one for all. This allows to use the InStreamer ICE now to distribute to many locations in a protected manner. The second thing we have added to the InStreamer ICE is a relay function. So what does it mean, relay? It means I can have one InStreamer ICE in relay mode subscribe to the main encoder with just one link and then provide link up to 100 listeners again. So I can have one in one city and not 100 people can subscribe. And if my relay subscribe, then in that city still 99 people can subscribe, but that new box allows another 100 people to subscribe. Especially when I do this on my intranetwork, this saves bandwidth. I only get one stream from one location to the next, but at that next location, multiple people can listen to the signal from the InStreamer ICE. So people use this, for example, to follow live proceedings of jurisdiction events, but you can also use this to do some internal screening across the country using InStreamer ICEs as distribution mechanism. The next solution I would like to introduce to you is the Barix Silence Monitor. It's shipping, and it is a device that monitors analog audio inputs for silence and alarms you. And it alarms you to an app on the phone. It can alarm as many people as you want. And the beauty about it is it will also give you more insights in what caused the silence by actually recording clips and allowing you to access those audio clips in the moment that caused the silence alarm. So with this, you can record any kind of live radio feed, continuous audio link, and be alarmed when it breaks. We have built this for the technicians that are maybe responsible for multiple radio stations, running their technology, running the transmitter side, and you can use this connected to an off-air receiver and basically get informed about any problems anywhere you are because it reports into a mobile app. So how does it work? Basically, you connect the analog input to this device, you register the device on a web service, and you download an app, load the mobile app, register the device against your app, and you're ready to go. And in the next few minutes, I want to show you how this is all set up. So first, I connect my silence monitor. One more time, I'm putting a loudspeaker so we can hear the IP address. I'm plugging the internet, and I'm plugging the power. I'm starting a browser, I'm entering the IP address, and I'm in the configuration screen of the silence monitor. Not much I have to do here. Basically, I can set the number of seconds with silence before I want an alarm, for example 7. The number of seconds with sound to trigger a sound is back alarm, for example 9 seconds. And I have a signal power threshold. So this is my threshold versus my audio level. So if I connect my radio to it, for our demo, I'm using some iPod that plays music. I can hear it plays music. And on the level display, I now see that the level is well above the threshold. So the next thing I need to do is I need to register this monitor with my cloud service. So what I do is I go to silencemonitor.com and I register an account if I don't have one, or I'm getting into here and I want to add a device. And my device is set up and ready to go. As a next step, I'm downloading the Silence Monitor app from the App Store on my iPhone and installing it. And this is how it looks. Here I can say Add Device, and I can read the QR code from the web page. It says, I have subscribed successfully. I say OK. And now I am monitoring this device for any alarm that it generates. I don't need to have the app actually open. I can close the app. I can put my phone aside. And I now simulate an audio alarm. So, an alarm went off. I can also suppress this alarm if I don't want that noise. And on my mobile, I'm actually getting access to the sound clippings that were recorded before it came back or before it broke. And I can listen to that. And I hear it broke in the middle of the song. So that sounds like a bigger problem than just having a playout file not being found or something like that. The beauty about Silence Monitor is I have it on my phone. I can combine as many boxes as I want. I recognize by the name of the device which station I am monitoring. I can make it accessible to anybody. So if I have more people that need to know, I just have them subscribe with a QR code. And whenever a silence is detected, they don't only just get an alarm, but they can actually listen at the last 5 seconds before that silence was detected. We're also clearing the alarm, meaning if the signal comes back, it will also log a message and say that the signal came back at that time. So I always have an overview over multiple channels wherever I am. This is Silence Monitor. It's a cloud service. It comes together with the Silence Monitor unit, 1 unit per channel, and this is shipping now. Barix in-streamer, X-streamer products, and especially the X-streamer 500 that's made for the broadcast market with XLR in and outputs, are still sold in the hundreds and thousands into any kind of broadcast application, and they continue to be the preferred device for a low-cost, high-quality audio link using IP technology or the internet. To make it simple, we have launched many years back the Barix Reflector service, which is run and operated by streamguys.com. It's a service where you pay a monthly fee in return for not having to hassle with fixed IP addresses and configurations and things like that. The Barix Reflector service has been working with MP3 signals only. Now, we've updated that service, and now Barix Reflector service can transport uncompressed streaming. So we can use the Reflector service to make a PCM link. It still supports the same features as the original Reflector service, including the ability to listen to the link on the phone, but it can run PCM signals now end-to-end. So either you use the Barix X-Streamer 500 on each side in order to provide an end-to-end PCM link, or you use it on one side and then use cloud transcoding services and other advanced services that you can get from StreamGuys. Both ways you get the best possible quality audio transport, still being able to rely on the simplicity and peace of mind of the Reflector service. So check it out at streamguys.com, the new Reflector service that supports uncompressed streaming. Barix provides a lot of other useful tools for broadcasters. One area where we have solutions is for intercom and paging over IP. And I don't want to go into details, but many people use the PS1 paging station to enable a very simple communication path, for example, between the transmission tower and the technology room, or they use one of our Barionet general purpose I/O devices that allow them to read analog or digital signals or to switch relays via an IP link from one side to the other. We have released a variety of new Barionet devices that are Linux programmable, and with these we can address particular applications that customers might have. We're very open to discuss with you your requirement and eventually providing Barionets programmed to enable the functionality that you required from a GPIO device. And coming, the IP Former, a very compact Ethernet audio decoder device with built-in amplifier. So you basically connect a 4 or 8 ohm loudspeaker to this, connect it to the Ethernet, and you have a streaming receiver for any application in the paging, announcement, background music environment. the IP former mounts to the screw holes of the 70 volt or 100 volt transformers, and therefore makes any standard loudspeaker an IP speaker. Talking about audio and pictures, Barix also makes products for TV broadcasters. Yes, also they need audio. Think the message here is Barix is actually very open to discuss with you your requirements. The strength of Barix is that we can use our hardware that we have fairly standardized to address a very wide variety of applications. With this, we can come up with cost-effective solutions for people that have very particular needs. To give you an example, we have been approached by a broadcaster who said he would like to replace his one-to-many communication system that they use in the studio technology rooms to talk to all their affiliates. We have built this 19-inch rack unit as an IP-based receiver for audio signals coming from one place being received on 200 plus places using the IP infrastructure. This product is based on Barix components, but custom built. So if you have a requirement for something where you think we might have the knowledge, we might have the components, but your product needs to be slightly different, please approach us. This is something we do quite a lot. We're working on customization of audio over IP kind of products for clients. Well, thank you for having followed this virtual NAB here at my home office instead of in Las Vegas. Barix continues to make products that meet the quality, reliability requirements of broadcasters at what we consider exceptional low cost. We offer services around our products for peace of mind, from the reflector to the silence monitor portal, and stay up to date with the latest technologies. What's most important, if we seem to be in the market of where you need a product for, but we don't quite have it, please contact us. We've built our product so that it is fairly simple for us to adopt them to different needs, as long as you need more than one. But anyway, looking forward to talking to you one-on-one. You can always reach me at reto@barix.com, and I surely hope we'll meet each other again next year at NAB. As in, it's a virtual NAB, so we're closing the formal and information part here, and now we have to virtualize the rest of Vegas. I've actually set up a poker table with my family, and it's a quite interesting experience trying to read their faces wearing masks. So I hope you enjoyed this virtual NAB from Barix. I hope you could take something away, an interest in the SIP Opus codec, or maybe an application for a silence monitor, maybe the new uncompressed reflector service by StreamGuys, or any other audio over IP application that you might want to discuss with us. If so, please contact us at sales@barix.com or contact me directly at reto@barix.com. Thank you very much for listening, and stay healthy.